Okay. All right, what I would like to review with you is very quickly like to review how to do linear regression. Okay, I've got another assignment up, very short one, that is a pure technology assignment. It has to do with given some data, using linear regression to represent the data and also to build a mathematical model that we can use. So I need everybody's attention, please. Folks up here. Thank you. Okay, so what we want to do then, let's take this data. We got this data table. I want to remind you guys, and I don't know, how many people know how to do this? How many people know how to input that data into a TI-84 plus and get back the best fit line? Raise your hand real high. I want to see how many people, just maybe one. Okay, so this is something we definitely need to go through. This is very important stuff. Here's what you do. Okay, we're going to go to, when you want to input data to do some kind of statistical stuff. And this technically is a statistical measure. We're going to do a best fit line statistically based on this data. You always go to the stat screen. And there's a bunch of things you can do in the stat screen. So we're going to go push the stat button on our calculator. And we got three menus here. We have the edit menu, the calculate menu, and the test menu. We're going to just use the first two. The edit menu is where we're going to input the data, and then the calculate menu is where we're going to calculate the equation of the best fit line, or let the calculator do it for us at least, okay? So we're just going to go ahead and hit enter, because we want the edit menu first option, which is edit. Okay, and you're going to see a screen like this. Okay, now if you don't get this screen, if you're missing one of these columns, and the L stands for list, by the way, when you're dealing with data entry on a computer or even in programming, when you've got a whole bunch of numbers that you want to be able to input to the computer or the calculator to have it do something with it, we call that a list, right? If you're missing one of those lists, it's possible, I mean, that, maybe you are now, maybe you will be later. Here's how you might end up missing one of those lists. First thing I want you to do is to go up and clear all the entries so we can start from scratch. Now to do that, you go up to the top of the column where it says L2, and you hit clear, enter, and it'll clear the whole column. Now here's what happens though, here's a common mistake. If I go over to L1 and instead of hitting clear, if I hit delete, look what it does. It deletes the column, and I can't find it. If I go to the left, it's not there. Okay, so I got problems. Not really. There's an easy way to fix this. All you have to do is go to the stat screen and go down to the fifth option, which is setup editor. So I can just push 5 and hit enter, and it'll tell me it's done. And now if I go back to the stat screen and hit edit, there it is. I got it back again. Okay, but I still have to clear it. So I go up to the top and I hit clear, not delete. I hit clear, enter, and now I'm starting from scratch. Okay, so all we're going to do here is we are going to input the x and y values. And I want you to remember, this is really important, that when we see x and y values, this is really sort of an inconvenient way to write that table. We'd rather write it as a t-table because then they look like ordered pairs. But these are just ordered pairs, right? X value, y value, those correspond to points, okay? So we're going to input all of these data points, these x and y values. I think the easiest way to do it is just to put in the x's first, because then you can just hit enter, fewer keystrokes rather than having to go over and down. So we'll just put in the x's first, so 1, enter, 7, enter, 13, enter, 15, enter, 20, enter. Take a quick look, it looks good. Now if I hit the right arrow, it'll scoot me over to the next column, to list 2. These are just going to be the y values. It's always that way. We always want the independent variable or the input variable in L1 and the dependent or output variable in L2, so x and y. Always have to do it that way. So then down here we'll just input the corresponding y values, 36, 29, 19, then you always want to do a visual check and make sure that you've got the same number of entries in both columns, otherwise it won't work. Okay, so we got it. Now that we've got that data, here's some stuff we can do with it. There's some cool stuff we can do with this data. First of all, we can represent it as a scatter plot, which is helpful. So to do that, now everybody do this once and you won't ever have to do it again. Let's go to set up our scatter plot. So if we go second F1 for stat plot, it's going to give us the options for our scatter plots. Now we want to do for our stat plots, you can do all kinds of things. You can do box and whisker plots, you can do histograms, you can do all kinds of stuff. We, 99 times out of 100 in this class, at least till we get to the very end, we're going to want to be doing scatter plots. And so let's just go ahead and hit plot 1. One is highlighted, so just hit enter, and it'll draw up plot 1 for us, and we'll see what our options are. First of all, is it on or off? Well, right now it's off, and that's fine. There's a shortcut for turning it on. If you look at the type of plot, there are 6 little icons there. The upper left one is the one that we want. That's scatter plot, and the default, because it's the most popular and most frequently used one. If we go down, this is also really important. X list needs to be L1. Like I said, the X is going L1, and the Y list needs to be L2. And then this may not seem like it's that big a deal, but you want the mark to be that little box. If you make it the dot, it's too hard to see. So make it that first mark. And it's probably just like that. These are all the default settings. Okay? Once you've got it like that, just hit enter. Whoops, actually we can just go up and hit Y equals. Go up to Y equals. Now you might have a graph plotted in there. I do. I'm going to get rid of that. I don't want that now, so I'll clear it. Now notice up at the top you see these 3 scatter plots. If they are highlighted, that means that they're on. So if I want to turn it off, I can go up and just hit enter and unhighlight it. Now nothing is being plotted. Okay? If I do want to plot it, I can turn it on. So I'll go ahead and turn that first one on. Now here's the question you're probably asking. If I want to plot that thing, how am I going to get the window set so I can see the scatter plot? Right? I'd have to pick X and Y values on my window so that I could represent the graph. There's a great shortcut. This is a good one. If I put in data, then I can plot a scatter plot based on this data. The calculator will figure it out for me, so it sizes the screen. If I go to my zoom menu, and I go down to the one that says zoom stat or zoom data, depending on the calculator. I can't remember which one. I think it's the 9th option. So if I go all the way down.
Zoom stat. Yeah.
All right, it's in zoom stat.
How do you get there again?
To zoom stat, use the zoom menu. If I push the zoom button, I get all these different options. Now let me tell you what zoom means for the calculator. Because we think of zoom as being, zooming in or zooming out with the camera. And it's sort of like that, but these are much better. These are much more specific kinds of zooming. First of all, the zoom standard, remember that's what we always want to hit when we graph something on a calculator rather than just hitting graph. This sets our window up to go kind of the standard starting place, where X goes from -10 up to +10, and Y goes from -10 up to +10. So you never hit graph, you always just hit zoom 6, unless you want to do something else that's more specific. Now what we're doing now is called zoom stat. Zoom stat is one where it's gonna automatically zoom the screen to fit the data. So if I just hit 9, and that's all I have to do in the future is just hit zoom 9 if I'm graphing data. Look what it does. It sizes the window so I can automatically, it spreads the data out so I can see it well. Isn't that cool?
What'd you do in the Y plot?
In the Y equals button, all you have to do is turn on the plot. Turn on the first plot, so it's highlighted, and then just go zoom 9, and it will do what we just did. It's going to size the screen so you can see your data.
It's still not doing it.
Zoom 9. Okay, you must not have it turned. Yeah, you don't have it turned on. So you got to hit enter to turn it on. Now it's highlighted, so it's going to plot. Now you go zoom 9. There you go. Okay. So everybody should see that. Everybody's got that? Now, first of all, what kind of correlation is that? Now, you guys have talked about this. It's negative correlation because it describes a line with a negative slope, right? If the dots were aligned so they described a positive slope, it would be positive correlation. What if they were aligned so it looked like it was a horizontal line? What do we call that? No correlation. Yeah, no correlation, meaning that these two variables are just, there's no connection. They don't cause, there's no cause and effect, right? Okay, in this case, there's a negative correlation, but we want to do better than that. We want to know what is the line that describes that perfectly. Now, you're probably used to doing stuff in the past where you'd graph that, and you'd get a ruler out, you'd draw a best fit line. That's kind of hokey, because we're all going to get different answers, right? What's the best answer? Well, the calculator can tell you what the best answer is. If I go back to the stat screen, and I scoot over to the calculate menu, look at the fourth option. It says linear regression. Okay? Now yours is going to be fancier. This new calculator up here, or the new calculators, the new operating system, for some reason we can't load it onto this smart view. But when you push 4, you shouldn't see that. You should see a screen that says regression menu or something like that. Here, let's make sure we all have the right stuff. Should look like that, exactly. Make sure everybody's, yours should, and if it doesn't look like this, if yours looks like mine, don't worry, I can update your system for you. You know, like when we're in the lab, I'll just update your calculator so it has the newest operating system. Yours should look like this though. You go to, what's your question? I'm sorry. You go to Stat, Calculate menu, 4. Stat Calc 4. Everything should look like this. Okay, good. Okay. Everybody's, yeah. Does yours look like mine? Yeah, that's good. That's good. Just hold tight right there for a second. Should everybody's look like this? Okay. Everybody over here look like this. Oh, is that one of the new ones? Oh, that's nice. Yeah. Okay, so then what you guys are going to do instead of this thing up here? Does yours look like that too?
Yeah, when I
No, I want to see if yours looks like this when you go regression. So if you go stat, cal 4. Yeah, it does. Okay, good. Okay, now listen, please. Listen. All you have a question.
Instead of L1 and L2, L8 and L7.
Okay, so we got to fix that. So we got to fix that on yours. So you want to go over. You want yours to be. Okay, so let me fix yours. This is pretty good. Yeah, it's just like. Now it's okay. Okay, so yes. Uh-oh.
It's stupid.
Okay, that's good. And you have to. Okay, so hold tight for 1 second. So when everybody has this screen, listen please. Okay, if all we want is the best fit line, all this is saying is the x variables are coming from L1, where it says x list L1. Good, that's what we did, right? That was that first column. The y variables, the y coordinates are coming from list 2. That's what we did. You can just skip all the way down to the bottom and highlight calculate and hit enter. Oh.
Go to.
You guys did data one. Oh, I didn't. Mine disappeared. My data disappeared on here.
No, I didn't.
I don't know why mine did, but it. Oh no, I didn't put it in on here. I put it in on here. Okay, so if you do that, if you go down and you hit calculate, you should see this, right? Okay. Now, there's a possibility you're not going to see the r squared and the r. Is that right?
Yeah.
Okay, if you're not seeing that, here's what you have to do. We'll go back to that in a second. But everybody should see the a and the b. Okay, that's the most important part. What that's telling us then is that the line of the form y equals ax plus b. So a is really our slope in this case, right?
Right.
Okay? The line, the best fit line with the form y equals ax plus b would have an a value of that, negative 1.47, blah, blah, blah. A b value of 37.269, blah, 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 right? So it's giving you, with spectacular precision, it's telling you what the equation of the best fit line is that fits that data. Pretty handy, right? So that's our model, okay? Now, on the questions like this one right here, it's just gonna ask you, on Moodle, it just wants to know, okay, using linear regression, find the best fit line, what's the value of m? It'll arbitrarily say, what's the value of m or b to 3 decimal places. So if it was asking for m, I would just input m equals negative 1.470, right?
You really need a 0?
No, you don't need the 0. That's fine. You can, it's not gonna hurt you. If it's asking for b, I would just input 37.2, now how do I round that? 2693. To what? No? Oh, yeah, you're right, never mind, 269, you're right. What if it was 2698? Yeah, 270, okay, everybody see that, or 270? Okay, so those are the answers it's looking for on those types of questions. Very simple. So you're just gonna input the data, but you gotta know how to do it so you get a little practice. Input the data, go to linear regression, get a best fit line. Very, very useful stuff. Yes, sir?
Does that have to be rounded to 1,000?
Yes, once it, on here, it doesn't say it in these instructions, but on Moodle it'll say round your answer to the nearest thousandth or to 3 decimals or something like that. It'll always tell you what it wants. Okay. What if, oh, and what about these r squared and r? That's also important, and I wanna show you how to get that on your screen if you don't have it. Raise your hand if yours doesn't have that right now. Okay, I think there's an easy way to do that if we go, if you just go mode, actually, you can do it on the mode screen now, you didn't used to be able to. So if you don't have it, do this, go mode, go down to next, hit the up arrow to go to next, so it skips you down to the bottom. And then on this side right here, it'll say Stat Diagnostics. Okay, the second from the bottom, Stat Diagnostics. Yours is off, it needs to be on. So just go highlight on and hit enter. Okay?
Yeah, we got it.
And then you can just hit quit. And if you go down and go second, enter, and then hit enter again, it'll go back and give you that. It'll repeat that last calculation. So has everybody got it now?
Yep, got it.
Got it?
Yep.
Could you do that?
Okay, so then, and you know, if you have questions on that kind of stuff, when we get to the lab, I can easily help you with that. Okay, now here's what this means. This is really important. This tells us how good is that model. So this is actually a really important thing to be able to see also. The line right here, R is what we call the correlation coefficient, but R squared is what tells us the strength of the correlation. R squared you can think of, and don't take this literally. Take this with a bit of a grain of salt, but it's a good rule of thumb and it's a good way to think about this. R squared tells us like the percentage compliance. So it's saying this is about an 86% fit. That's pretty good. If it's 100% fit, that would mean that the data points all were exactly on the line, right? If it were a 0% fit, there would be no correlation at all. Absolutely no conceivable way to get any kind of a best fit line out of that. So this is not bad, and you can see it's not bad when we look at the graph. We can see that there's definitely a negative linear trend there, right? Everybody agree? Okay, but now there's another kind of question that I want you to see here. If we go to something like this, it's asking you to do something different. It's asking you to do something more significant than what you just did. It's giving you this linear information. And it's saying, use the linear regressional model based on the data above to predict the value of y when x equals 27. Now this is why we do this stuff. The main purpose of math in everyday life is to build models that we can use to make predictions. Math, and a lot of times that's based on physics or something like that, right? Or like when you want to know what the temperature is going to be over Memorial Day weekend, and you look on the newscast and it's showing you, oh, it's going to be, it's pretty accurate now. You know, I mean, it's uncanny. It didn't used to be that way. but it's not bad. How is it doing that? Well, there's some really complicated mathematical model that's crunching a bunch of data that's making a prediction for this area. Based on the mathematical model, what's the temperature going to be? So it makes a prediction. So on a much smaller scale, that's what we're doing here. So let's do this one. I want to show you how to do this problem real quick. Go in and change the data just so we can verify the answer. So just go into stat, edit, so just stat, enter, and you can either clear this stuff or just right over the top of it's fine, because we have the same number of data points here. So put in the x values. Okay, and I gotta get these in there. Okay, well, first of all, let's just verify that we got this right. If I want to, now notice if I hit graph, that's not a good idea. If I hit graph, it doesn't show up very well because I'm using the window settings from the last stat problem that I did. So what do I want to do instead? I always want to start with the zoom menu. Zoom 9, good. Yeah, zoom stat. So I'll go zoom 9, and it'll size the window for me, right? Okay, that's different. What kind of correlation is that? Positive. Looks like it's maybe even a little better correlation. We'll see, I guess. So if we want to know here, though, what the value of y is when x is 27, we got to build this model. We got to know what the regressional model is. So we could go back to the regression screen. Now everybody needs to. I need everybody's total attention up here, ladies. Turn around, face. This is big. If you don't get this now, you're going to stumble on this a little bit. So stat, calc, 4. And then if I just go down and hit calculate, it tells me all that stuff. But, so one option is, I could write out y equals that huge decimal times x plus that huge decimal, and I could just go in and input these x values, right? Except, or input the x value 27, and that's the model that's going to make the prediction for me, right? That's a lot of work, though. The calculator can make this much easier. Watch this. This is really cool. If you go back to that regression screen, so once again, stat, calc menu 4, and yours looks a little different. Go down to the line that says store reg EQ. That means store regression equation. If you skip down to that one, and we want to store it as y1, because when you go to the y equals menu, notice these are like y1s and y2s, and so we can store equations in there. What we're gonna do here, this is great, we're gonna have the calculator make up or calculate the equation of the best fit line for us and input it as y1, so we can actually look at the graph and use the graph of that line. Isn't that cool? So then we've got our model graphed on the calculator with all the features available for us to use to explore that model, right? So how do we do that? Okay, there's a shortcut. I'll show you 2 ways to do this. I'll show you the long way in case you forget, and then I'll show you a quick new shortcut. So stat calc 4. What you would have to do there, whoops, stat calc 4. There we go. Okay, what you'd have to do is put in a y1 there. Okay, now how do you get to y1? There's 2 ways you can do it. You can go, the long way is to go through the whole menu system. So notice there's a menu or there's a key on your calculator that says VARS for variables. If you press the variables button, you can access all the different kinds of variables. Well, we want the y variables. So you scoot over to the y variables menu and we want a function. And so then I get the choice, which one do I want? y1, how about? Okay, and if I put a y1 in there and I hit enter, it's going to do the same thing it did before, but look at that. If I go to the y equals menu or the y editor, it's got that input for me already. And so if I go graph, look at that. How about that? Not only do I have my scatter plot, I've actually got the line graphed. How cool is that? Okay. Now the shortcut is this. You don't have to go through that whole, all those menus. You can just do this. You can just go stat calc 4, and where it's asking you for that y variable, I don't know if mine will have it, but you can go alpha F4. Yeah, it does. And so
Oh, yeah.
if you hit alpha F4, it pulls up all those Y variables, and so you can just hit enter, and it'll input that Y variable just like that. Okay? And I hit enter again. It makes the calculation. More importantly, it puts the graph up here, right? Yep.
It works.
Oh, okay, no, okay, yeah, you want to keep that as L1. It's down here. This is the line where you want it. Okay, you want to put it on the store regression equation line. So let me make sure everybody's got that first. Everybody can get the line in there. Good. We all got it? This table? Everybody got it?
Yeah, we did.
Okay, did you get it? Good. Good. So then you go ahead and just hit graph and mark after them. Good, you got it. Everybody got it over here? Okay, excellent. So now what this does, and this is a really important point, I can't tell you how cool this is that it does that. I mean, that is really pretty remarkable that your calculator now can do all that stuff so easily. If I want to make a prediction, maybe this data has some real world connotations. It's based on real world data. If I want to estimate, let's say this is a small sample of some real data. Let's say if I want to make an estimation of what the most likely value is going to be when x equals 3. Is it 6? No. Even though that's what my sample of data was, is 6 the most likely outcome? No, it's not. Because there's always going to be a little bit of individual variability when you take data. For example, if we were measuring, let's say, age versus height for teenage boys or something, right? There's going to be quite a bit of variability. You know, for a given age, there's going to be quite a bit of height variability in our sample, right? And so, you know, it wouldn't be surprising if one person, if we're looking at 16-year-olds, we might have somebody that's 6'2" and somebody that's 5'2", and it could be all over the place, right? But if we took all that data and we made a best fit line out of it, it's going to statistically average that in a way where it's going to give us the most likely outcome. We'd build this linear model, and then we'd input 16 for age, and it's going to spit out what the odds are it's going to be. Now, it might be a little different, but it's going to be the most likely result, even if it's different from the individual data that we gather. Does that make sense? So the best answer, if I want to know what's the most likely outcome when x equals 3, here's what I do. All I have to do is use this linear regression model. I don't even need the scatter plot anymore. I could go up to y equals and just unhighlight the scatter plot just to get rid of it, so it's not even cluttering up the screen. Now there's my linear model. That is the regression line, the best fit line. If I want to know the value of y when x equals 3, all I have to do, I'm going to show you once again, I'll show you the menu way and then a shortcut way. You can go second, calc, always gets you to the menu of stuff you can do with a graph. There's a ton of really good stuff there. Now some of this, like items 6 and 7, are really calculus things that we'll do a lot in calculus, and we probably won't do a ton with that stuff this year. But a lot of the stuff up here we will. The first 5 we'll use all the time. The very first one is evaluate. Okay, that's a really big one. So if I want to know the value of the function, I can feed it an x value. So if I hit enter on number 1, and I input an x value of 3, watch what it does. This is super cool. When I hit enter, it will put the cursor on that point, and it'll tell me the ordered pair. When x is 3, the most likely y value is that, based on our model. Yes, sir?
I can't grab it, so it's invalid.
Invalid dimensions? Okay, well, it might do that. Let's see what's going on. So if you go, we'll go, well, hold it. Okay, hang on. Here's something. I'll show you a trick. Oh, there, you grabbed it. You grabbed it. Why don't you sit with somebody else at the table too, so you guys can kind of compare notes a little bit. It's going to be real important that we have people we can touch base with. Okay, so did everybody see how we did that? Second calc value. There's another way to do it. If I just got this thing graphed, I can do it in one quick step. If I've only, now here's the caveat. This only works if there's one function graphed at a time, which most of the time that's what we've got. If so, I can just hit the trace button, and it's gonna give me the x and y coordinates of whatever point I happen to be on the graph. But if I just type in the x value that I want, 3, look what it does. It says x equals 3, and if I hit enter, it'll put me specifically on that x value. So trace, type in the x value, hit enter, and it'll evaluate it for me also. Okay? So what do I want to do here then? When I'm answering this question, what is it I want to do? If I want to find the y value when x is 27, what do I need to do?
It tells us that it's incorrect.
Okay. It tells you, if I try to put in 27, it tells you something bad, right? If I try to go trace 27, it says error invalid. Here's why. I'm going to tell you why that happened. And maybe that's what people were doing to try to, Okay, here's what you have to have. The x value that you're inputting must be contained on the screen. Now the y value doesn't have to. That doesn't really matter if the y value is off the screen, but the x value has to be included in our window. So if I want to input a value of 27, what is my window doing right now? Well, if I go up and hit the window button, I can actually see how the screen is sized. I guess I have to do that first. If I go window, now look, my x minimum, so that's the left edge of the screen, is at 0.8, and my x maximum is at 15.2. So I could only use x values greater than or equal to 0.8 and less than or equal to 15.2. What do I need to do if I want to check 27?
Increase the maximum to 27?
Yeah, I gotta make my x maximum bigger, don't I? Because it's not big enough. So if I went down and made x maximum something like, I don't know, 35, 36 would work, 30 would work, I'll just pick 35. This is gonna work, but I also want to be able to maybe see this on the screen. So here's another great little zoom trick. You'll get a ton of mileage out of this. If I set the x parameters, so I set the x minimum value and the x maximum value, which really just means the left edge of the graph and the right edge of the graph. If I want the calculator to pick the y values so that the graph will look pretty, I can just do this. I can go zoom fit. It's going to fit the y values to the x values that I picked. It's zoom 0 is the 10th option. And you can just remember it's zoom 0, and it'll think for a second, and it'll graph it for me. But it's extended now. It's extended the window out far enough that I can include that point. So, yes, ma'am. Say, how did I get rid of them? I just went up to y equals, and I unhighlighted plot 1. You don't have to do that, but it's actually more convenient to get rid of them. Just because they're, they're sort of in the way a little bit. Okay? Okay, so now if I go back to my graph, all I have to do is just hit trace 27, and look what it does. It tells me the y value.
Still says invalid.
Okay, then you must not have reset the window. Is anybody still getting that invalid?
No, I thought you said instead of doing this. Yeah, I know that. Yeah, I know that. But he said, I thought he said instead of doing that.
No. You have to set the x's first and then hit zoom fit. The zoom fit will scale the y's, but you have to tell it how big you want the x's. Okay, everybody okay with that? Does that make sense? Yes. Okay, but you have to get the graph. So there's your graph. So now let's go up to y equals. Oh, okay. So did you have the plot up there further? Oh, you must have deleted. Okay, so all we have to do then, fine. You just go add val or so now that puts it on. You have data?
If you're looking for your customer,
Oh, was it? I don't know what it was. You must have. Oh, it is. Okay. Yes. All you want to do is just go up and unhighlight it. Now, if I go now I can just go trace. Okay, makes sense? Anybody else get it? You guys get it over here?
Yeah.
Okay? Okay, now, I will, obviously, okay, there's a lot of stuff there, right? There are 2 resources I've got for you initially. Once you've done this a couple times, it'll just be old hat, you won't have to worry about it. But initially, you may think, now, how do you do that? Okay, I put under the Unit 1 handouts, I put a little PDF that's got it's just an example. Better than that, today, I will for sure get this. I've got all the stuff set up to where, at least at home now, you should be able to view the YouTubes. And so I'll put a link on there to my YouTube homepage, and you can just go to the appropriate playlist. It'll just be Honors Algebra 2, Unit 1 playlist, and I'll just make sure everything's up there for you, okay? So you can go see this stuff if you need to.